Okay, this is a short tutorial on how to answer the roller coaster physics lab analysis and conclusion questions for 8th grade science. The first one, the pre-lab questions, you can find all of these in your notes, 6.1, and if you don't have those notes with you, you can just simply look up those definitions on the internet, because that's what they're looking for, the definition of potential energy, kinetic energy, and gravitational potential energy. At the bottom of this page, we're just looking for a sketch of your roller coaster. Make sure that you've named it, because that will be on one of the other questions on the next page. So remember, our roller coaster had 2 wheels, and you just need to kind of sketch that out there. All right, we want to look at our hypothesis, and the hypothesis for what the question was, how does the shape of the track affect the speed of the cart? And you need to think about where the speed is greatest, where the speed is lowest, and then hypothesize how the shape's going to change that. Remember that our speed is greatest at the bottom of the hills, and that's due to kinetic energy. That's where you have the highest amount of kinetic energy. And our speed is lowest at the top of the hills, because that's where I have the greatest amount of potential energy. So if I increased the size of the hill, I would increase potential energy, which would then increase the kinetic energy, and then that would increase the speed of the cart. Now, you will need to put those things in your own words. I'm just giving you a review of what I'm looking for. So in your own words, you need to say something about how if you increase the size of the hill, that increases the amount of potential energy the car has, which will also increase the amount of kinetic energy it has, which then in turn will increase the amount of speed that it has. You should have gotten a length for your roller coaster. I'm just going to put in the numbers that I got for my data table, and these numbers are just kind of made up numbers, but I'm going to show you how to do the calculations based on these numbers. So in trial 1, I have 1 second, then 1.5, 1.8, 2.0, 2.2, 2.3, 2.0, 2.1, 2.4, and 2.1 again. And then I take the average by adding all of those and divide by 10. Now, if you didn't have 10 trials, then you would divide by however many trials you had. Some people had 10, some people had 5, some people had 3. Okay, so to find average velocity, what I'm going to do is I'm going to take my length, 3.5 meters, and I'm going to divide it by my average time, 1.94 seconds. And when I divide that out, that gives me an average velocity of 1.80 meters per second. Now, when you do that, you'll need to give me 2 decimal places will be fine. Our height of the roller coaster, again, you were supposed to measure this. I'm just going to give you some made-up numbers here. Let's say 0.7 meters for the highest point. Yours also had the lowest point on there. This is a little bit different version than yours, but the lowest height was 0.16 meters. The mass of your cart, for my cart that I weighed, it was 0.069 kilograms. Now you need to do your mass in kilograms, not grams. And then you'll need to name the roller coaster. Okay, the post-lab questions. How many points on your roller coaster allow you to observe potential energy? Well, remember that potential energy is always the tops of the hill, and since we had 2 hills, we would have 2 positions of potential energy. And kinetic energy is always the bottom of the hill, so we had 2 bottom of the hills. So again, we would have two positions of kinetic energy. What would you do differently in constructing your roller coaster? There are all kinds of things you can put in here. Please do not just say, I would make it better. I need to know what you think you should do to make it better. And there is no wrong answer for that one. So, number 4, list any other forces or types of energy that may affect the actual roller coaster in a theme park. Well, one thing that we are not able to calculate is the effect that friction has. Friction is a form of energy, or it's a force that acts on it, and it will affect how fast the car goes and different things like that. And we haven't taken that into account. Sound, and some of that energy can also be lost to sound. And there could probably be some other ones that you could think of to put in there. So again, there's not really any wrong answer for that. Number 5. If height, weight, or other points of energy changed, how would the experiment change? Well, again, we talked about this earlier. If we were to increase the height or the weight of the car, the mass of the car or the height of the hills, that would increase potential energy and therefore increase kinetic energy, and then that would increase our speed. And that is because of these two equations. These two equations say that potential energy is directly related to the mass and the height, and kinetic energy is related to the mass and the speed. We also know that according to the law of conservation of matter, potential energy is supposed to equal kinetic energy. So if I increase one, I increase the other, and then that has an effect on the speed of the cart. Okay? All right, there are a couple other problems that you have on your sheet that are not necessarily listed here. Okay, so we are going to do a couple of calculations now. On your page, you had a number 6, which was to calculate potential energy. So we're going to just plug into our potential energy formula. Potential energy is equal to the mass of the cart, which I said was 0.0697 kilograms, times acceleration due to gravity, which was 9.8 meters per second squared, times the highest point on our roller coaster, which is 0.7 meters. And I'm simply going to multiply all three of those numbers together, and I get 0.47 joules. Number 7 asks me to calculate the kinetic energy of the cart. So to do that, I'm just going to take half of the cart's mass times its speed squared. And remember, our speed was 1.80, at least my speed was 1.80. Remember, you can plug all this into the calculator, but you need to make sure that the 1.8 is squared. Then you'll multiply by the mass, and then you'll multiply by 1/2, which is the same thing as 0.5. When we do that, we get 0.112 joules of energy, kinetic energy. Question number 8, the last question, says, law of conservation of matter, and energy states that energy cannot be created or destroyed. So why is my calculated values for potential energy different than that for kinetic energy? If you can't destroy energy, why are they not the same? And the answer to that is that some of the potential energy is quote-unquote lost to friction and sound. It's turned into friction and sound energy, and so it's no longer what we would consider usable energy. It's no longer kinetic energy. But it is not destroyed. It's just been transferred to a different form of energy, and that's why they are not the same. Okay, so I hope this helps as you are filling out this lab. Remember, we will be grading this on Tuesday when we get back. Please make sure you have all these answered in your notebook. All right, have a great day.